Let's continue our lesson with theory of gelation. In polymerization of polymer, gelation gives a clear indication that polymerization has started, meaning that your polymer has started to develop. Gelation is the formation of a gel from a system with polymers. If monomers containing a functionality greater than 2, which means that if you polymerize monomer with functional group more than 2, change branching results mean that it is high probability for you to form a polymer with branching. If the reaction is carried to a high enough conversion, gelation occurs. Therefore, during polymerization reaction, it is important for us to determine the onset of gelation, or also known as gel point. It is the time where gelation of polymerization is started. So the clear indication of gel point is when you do polymerization, there is sudden increase in viscosity such that the polymer undergoes an almost instantaneous change from a liquid to a gel. So in branch polymers can form links between the change, which lead to progressively larger polymers. So for a branch polymer, the polymer is a true network polymer and the cross-link density will increase. So this can be seen as the increase in viscosity during the polymerization reaction. Even though gelation gives the first indication that polymerization has started, excessive gelation makes stirring during polymerization difficult because of very high viscosity. So it is important for us to predict the gel point during the polymerization. This is because if gelation is too much, there will be an increase in viscosity, which makes stirring becomes impossible, and therefore it is difficult for you to produce polymer with very high molecular weight. So to predict the onset of gelation, or also known as the gel point, we can use the characters equation that using the average functionality of the monomers involved. Now let me show you on how to find average functionality in a polymerization reaction. So let's look at this example 1 in the preparation of polyester. So in this example, polyester is prepared by using equimolar mixture of phthalic anhydride, trimethylic acid, ethylene glycol and glycerol. So there are 4 different monomers are used in the preparation of polyester. To find average functionality, first you must to determine the number of functionality of every each of the monomer. So let's take a look for the first monomer, which is phthalic anhydride. So the number of functionality of phthalic anhydride is 2 because it has carbonyl group here 1 and this is another carbonyl group 2. And next, for trimethylic acid has 3 functionalities. So it has carboxyl group here 1, this is the second carboxyl group and this is the third carboxyl group. So the functionality of trimethylic acid is 3. Same goes to ethylene glycol. The functionality of this monomer is 1 OH group and this is another OH group. So it has 2 functionality. And last monomer is glycerol. It has 3 functional group of OH. So to find average functionality, you have to sum up all the functionality of each monomer, 2 plus 3 plus 2 plus 3 divided with the number of monomer involved, 1, 2, 3, 4. So divided with 4, and the value of average functionality that you get is 2.5. According to Carter's equation, gelation occurs when degree of polymerization becomes infinite. So to relate the gel point with degree of polymerization, it is required for us to know the critical extent of a reaction, PC. So PC, the critical extent of a reaction, can be calculated using this formula, 2 divided with average functionality. So if you still remember, during our previous example of the polymerization of polyester, we have calculated the value of average functionality, which is that the average functionality obtained from the previous example is about 2.5. To find the critical extent of reaction for that polymerization, we can use this formula, critical extent of reaction equal to 2 divided with average functionality, which is 2.5. So we got the value of 0.8. So in degree of polymerization, 0.8 times 100, we get the reaction conversion of 80%. Therefore, we can say that in that polymerization of a polyester, gelation would occur when the reaction conversion of reach about 80% of conversion. Let's try to do this exercise together. So in this exercise, you need to calculate the average functionality and critical extent of conversion for a glycerol phthalic acid with molar ratio of 2 to 3. So in this question, you have the number of mole of both monomers, which is the number of mole given to glycerol is 2, and the number of mole for phthalic acid is 3. So if you have the number of mole of a monomers, to find the average functionality, you need to find the equivalence of both monomers. To calculate the equivalence, first it is easier for you to draw a table. So the first one here, the first column here, you may write monomer, which is the components of the reaction, and then the number of mole, and the third column is the functionality, and lastly is the equivalence. So you can draw a table here. Okay, so the first one is the monomer. Your first monomer is glycerol. Number of mole of glycerol is 2, which is given by in the question. So you write 2 here. And for functionality, you need to find the functional group of glycerol. So it has 1, 2, 3 OH group. So you write 3 here. And the equivalent is moles times functionality, which is 2 times 3. So you got 6. So finish with the first monomer, then you write for the second monomer, which is phthalic acid. So the number of mole for phthalic acid is 3. The functionality of phthalic acid, so you have carboxyl group 1 here and another carboxyl group here. So you have 2 functionality, and the equivalence is 3 mole times functionality. 3 times 2, so you got 6. And then find the total number of mole. 3 plus 2, you have 5. And then the total number for equivalence is 6 plus 6, you have 12. Okay, finish. And then you find the average functionality, FAV, which is equal to the total number of equivalents, 12, divided with total number of mole. 12 divided with 5. So you get about 2.4. So this is the value of average functionality. And the critical conversion, critical extent of reaction, PC. So the formula for PC is 2 divided with average functionality. So you have 2 divided with 2.4. Then the answer is 0.833. So you can say that the gel point will occur when the polymer achieve reaction conversions of about 83%.